Good morning one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today our topic is soil nailing. It is one of the important technique in our ground improvement techniques. So it is used, which one we are going to use to enhance or to reinforce or stabilize the retaining walls, to stabilize the slopes and also the retaining walls. So it is soil nailing is a construction technique which we are going to use to reinforce and stabilize slopes and retaining walls. It involves inserting steel bars or nails into the soil. That's why this is called as soil nailing. So whenever we are inserting the steel bars into the soil which are grouted to create a cohesive mass that resists movement. So in this, the purpose of this soil nailing is stabilizing slope, reinforce the retaining walls, support excavations and prevent landslides and erosions. These are the major purposes for this soil nailing. It is going to apply in highway and railway cuttings, deep excavations in urban areas, bridge abutments and landslide remediation. These are the various applications which we are going to choose this soil nailing technique. So, in these different types of components are there. Those are nails, grout, shotcrete and drainage. These are the components. These nails, it is typically steel bars or tendons which are going to inserted into the pre-drilled holes. So this is whenever they are going to insert in pre-drilled holes. In grout, it is nothing but the cement-based material which we are going to use to fill the drilled holes and bond the nails to the surrounding soil. So cement-based material. So it may be different types of cements. We are going to grout which type of cement or which type of material we are going to choose for getting that bond to the surrounding soil. It depends upon the condition of the soil and it depends upon the properties of the soil and desired properties of the soil for the construction work. Based on that, we are going to choose this grouting material. And this shotcrete, sprayed concrete applied to the exposed soil surface to provide additional stability and protect the soil face. So in this sprayed concrete, we are going to apply to expose the soil surface to provide additional stability to protect the soil face. Such type, in this concrete also, the sprayed concrete, it involves some materials. It is also depend upon the which type, the grade of cement or any combination of cement is there. It is depends upon the desired properties of the soil. Whatever the soil properties we require for the construction, it depends upon such type. It depends upon the condition. So this is also one of the component which we are choose for this soil nailing component. In the drainage system installed to manage groundwater and reduce hydrostatic pressure behind the nailed wall. So it is depends upon this drainage component which is depends upon the groundwater level. So how we are going to manage that groundwater and also for reducing the hydrostatic pressure behind the nailed wall. And so in this, different types of soil nails are there. Those are driven nails, grouted nails and self-drilling nails. These are the different types of soil nails which are going to available for getting the desired properties. In that driven nails, these are the steel bars or tubes. They are going to driven into the soil without pre-drilling. So without any kind of pre-drilling, they are going to driven into the soil. Such types of soil nails are known as driven nails. This is already we understood. Based on this, they are going to driven into the soil without pre-drilling. It is nothing but the faster installation. No need for any kind of drilling equipment. And also it has one limitation, that is nothing but the steel bars are going to driven, means they are such type of soil is softer soil. And also it may cause the soil displacement. For harder soils, this type of driven soils are not suitable. And next, move on to the grouted nails. These steel bars are into pre-drilled holes and grouted in place. So strong bond with the soil, suitable for all soil types. Requires drilling and grouting equipment. This is the grouted nails. Self-drilling nails in hollow bars with some kind of sacrificial drill bit that allows simultaneous drilling and grouting. So that such type of nails are known as self-drilling nails. They are going to simultaneously they are going to drill and they are going to install. They are going to insert, they are going to ground, and at a time they are going to install. Such type of effect of installation suitable for difficult ground conditions. So, but in this, it's already we are understanding self-drilling means it is automatically drilling and it is going to installation. It means it requires high cost and also the materials, the high cost materials and equipment. So these are the different types of soil nails are there. Those are driven nails, grouted nails and self-drilling nails. What are the various design considerations for soil nailing? This depends upon the soil properties, slope geometry, load requirements, nail length and spacing, surface protection. These are the major design considerations for the soil nailing. Coming to the soil properties, for which type of soil, which type of nailing is suitable for this, it depends upon the soil conditions in sometimes. So understanding the soil characteristics and including type, strength and cohesion, it depends upon the which type of soil we are going to conduct this technique. It is also very, very important. And also which type of property we require, that is also important. So based on this, we are going to understand the characteristics of soil including type, strength and cohesion. And next one is the slope geometry. In this slope geometry, we are going to assessing the slope angle, height and overall geometry. So we have to understand because of the how much drilling is required, and self-driven soil nailing types are also there for choosing those. So for that we have to understand the slope angle, height, overall geometry of the soil nailing for the soil nail conditions. In load requirements, determining the loads, the soil nails must support including static and dynamic forces. So it depends upon the which type, whether it is static or dynamic forces. Based on the, we are going to choose the load requirements. Will also plays a crucial role for the design considerations of the soil nailing. In move on to the nail length and spacing. Calculate appropriate length and spacing of nails to achieve the stability. So in stability point of view, how much length of the soil nailing is required, how much depth it is going to. So these kind of properties are important in, and also the spacing between them also important for understanding the soil nailing and getting the desired considerations and desired properties. This is also one of the design consideration. In surface protection, so deciding on the type and thickness of shotcrete or other surface protection methods. So these are the design considerations which we are going to consider for the soil nailing. In soil nailing installation process, site preparation, drilling, insert nails, grouting, applying shotcrete, installing drainage. These are the very important steps which we follow for the soil nailing installation process. So in this site preparation, so clearing vegetation and whatever the slopes and devise these from the slope, and also set up the SS and safety measures for the work site. So we are going to prepare the site whenever we require the soil nailing. We are going to prepare the site. That is the very important aspect. First we are going to clear all the vegetation and we are ready to install the soil nailing. Like that we are going to prepare the site. The next step is, the next procedure is drilling. Now we are going to drill holes into the soil at required depth, and whenever the locations, already we know the locations and angles, as per that we predetermine the locations and angles. So the hole diameter and depth depend upon the design specifications. Based on the design consideration, we are specifically for the particular, we are designed specifically for that condition. So this drilling, some self-driven soil nails are there. There is not requirement of drilling type of nails are also there, and also they are there, but there where we are executing in soft soils only. That is also we have to keep in our mind. So after the drilling, the next step is inserting the nails. So inserting steel bars or tendons into the desired drilled holes. So as per predetermined locations, we done the drilling process. After that we are inserting all the steel bars, ensuring proper alignment and positioning of the nails. So we have to ensure the alignment and positioning of the nails as per the design specifications. Already we consider design consideration. According to that we design this soil nailing type and whatever the soil nailing length and everything we are going to fix it. So according to that we are going to ensure that alignment and positioning of the nails in inserting the nails. The next process is grouting. Now pumping grout into drilled holes to fill voids around the nails, ensuring complete whatever the encapsulation of the nails without grout, and applying shotcrete. Shotcreting on the exposed soil surface, we are doing this shotcreting, so to provide additional stability and protection. So applying in layers to achieve the required thickness and coverage. So that comes under this applying shotcrete. Next one is installing drainage. So installing drainage systems such as a weep holes or geocomposite drains to manage groundwater and reduce hydrostatic pressure. These are the steps we are going to follow for the installation of the soil nailing. So once we done this site preparation, drilling, we are inserting nails, grouting, after that applying shotcreting and installation in the drainage system, we complete whole installation process of the nailing. The next, once we done with the soil nailing, next step is the monitoring and maintenance. So it requires regular inspections, load testing, drainage maintenance and surface repairs. These are very important. After completion of the nailing, the regular inspections for signs of any kind of movement, nail corrosions and shotcrete degradation. It may happen any sort of the things we have to monitor. And once we observe any sort of these kind at the time of monitoring, we are move on to the next. We are going to maintain. We are going to replace or whatever the things that desired, whatever the final output is, should be like that. For that we have to do whatever the things we will do for the getting the things safe. So in this, the checking signs for sign movements, nail corrosion and shotcrete degradation, and also we may observe any sort of these at the time of monitoring. We are going to do the load testing, and also periodically this testing of nails is ensure they are carrying the expected loads or not. So once we have done these loading tests, they are going to within the expected loads, it is okay. Otherwise we are going to maintain the things. So drainage maintenance. So ensure drainage systems are functioning correctly and are not clogged. So these are the things we are going to monitoring. Surface repairs. So repairing any cracks or damage in shotcrete surface to maintain stability. So for maintaining stability or carrying the expected load, for that what we have to do, we are going to do for the longevity of the structure. So for example, in case studies, highway slope stabilization is one of the example. That highway cut slope in a mountains region we are considering. In that such type, installation of grouted soil nails and shotcrete facing. So to improve the slope stability, reduce maintenance cost and enhance the safety for highway users. This is the outcome for this condition, highway slope stabilization. And the next one is urban excavation support. In deep excavation for a basement in a densely populated urban area, we are used in this particular technique use of self-drilling nails and temporary shotcrete facing. So the outcome is safe excavation, minimal disruption to surrounding buildings, and efficient construction process. In this, minimal disruption to surrounding buildings and efficient construction process and also the safe excavation. So in these advantages of the soil nailing, it can be various we may use various soil types and slope conditions, and also more economical compared to the other stabilization methods, and also it can be minimum disturbance to the existing structures and vegetation, and also flexibility. Allow for incremental construction and easy modification if we need it. These are the advantages of soil nailing. In these also limitations, installation challenges requires specialized equipment and skilled labor. Corrosion, long-term durability can be affected by nail corrosion, requiring appropriate protection measures. Ground conditions, less effective in very loose or saturated soils. We may use in those conditions also, but they are going to less effective in very loose or saturated soils using this soil nailing. In these concerns and mitigation strategies, corrosion protection using galvanized or epoxy coated nails and to prevent the corrosion. Quality control, ensuring proper installation through regular inspections and load testing. Environmental impact, minimizing the disturbance to the surrounding environment and adhering the regulations. Groundwater monitoring. In groundwater management, installing effective drainage systems to manage groundwater and reduce hydrostatic pressures. Use advanced materials, innovation installation techniques, monitoring technologies, sustainability are the future trends in soil nailing. In advanced materials point of view, development of high strength and corrosion resistant material for longer lasting nails, automation and robots for more precise and efficient nail installation in innovative installation techniques. In monitoring techniques, real-time monitoring systems to track soil nail performance and detect any potential issues early. Sustainability, use of environmental friendly materials and techniques to reduce the environmental impact of soil nailing projects. Soil nailing, it is a crucial technique in geotechnical engineering, providing essential support and stability for slopes, retaining walls and excavation. Proper design, installation and maintenance are vital for ensuring the safety and longevity of the soil nailing structures. Advances in materials, installation techniques and monitoring technologies continue to enhance the effectiveness and reliability of soil nails in geotechnical applications. These are some of the web references. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.